Hi everyone, welcome to Cloud Computing series. In this video, we'll be learning about cloud computing over the internet. Gordon Bell, Jim Gray, and Alex Zales stated that computational science is becoming data intensive. That is, science today involves handling a very large amounts of data, not just doing the calculations, but managing and processing huge data sets like in weather prediction or a DNA research. And supercomputers should not just have a fast processors, they also need a faster data storage and a strong networking to handle and move large amounts of data quickly. Yes, they send the computations to the data, not data to computers. Instead of downloading a huge data files to your own computer, we should send our programs to where the data is stored and process it there. Yes, this is faster and more efficient. Then next is, see, in the past, people ran programs and stored files on their own computers. Now everything is moving to big data centers and powerful places where software, hardware, and data can be used online, like Google Drive or a Zoom. See, cloud computing is promoted by a rapid data growth. As the data grows too big to handle on our personal devices, we need a cloud computing where everything is stored and processed online. The IBM defines cloud computing as a cloud is a pool of virtualized computer resources. That is, cloud computing uses many computers that are combined and shared using virtualization. And it is a way to divide one powerful machine into many virtual machines. And it can host different kinds of work like back-end jobs or apps. So the cloud can run background tasks like a data analysis or a user-facing applications like websites or games. Then next is the key features of a cloud computing. Rapid deployment and scaling. You can quickly start using a new virtual machines or increase the power of your app. Yes, this is like adding a more servers instantly when you need them. No need to buy hardware. Then redundancy and self-recovery. See, cloud systems are built so that if one server fails, another takes over automatically. This makes sure your app does not crash. It self-heals. Then highly scalable programming models. The cloud platforms are designed to grow or shrink resources based on demand. For example, an online store can handle a 1000 users or a 1 million users by automatically adjusting resources. The next feature is real-time resource monitoring. So cloud systems constantly watch how much CPU, memory or storage is being used and adjust things to keep the system running smoothly. And the next topic is internet clouds. Computing is based on a virtualized platform that provides elastic resources on demand. That is, as we all know, cloud computing uses virtual machines instead of real ones. Yes, it can increase or decrease resources like a storage, RAM, or a processors automatically based on a user need. This is called elasticity, and it dynamically provisions hardware, software, and data sets from large data centers. That is, cloud can instantly provide the hardware, software, and data you need from a huge data centers without you buying any physical devices. And this diagram shows how cloud computing works. A user sends a request to the internet cloud, which is a large group of connected computers. And the cloud provides different services like a hardware, software, storage, and network to the user on demand. Yes, these services are virtualized and paid for as needed, making it flexible, cost effective, and easy to use. Then moving to the next. Instead of running everything on your personal computer, the goal is to offer everything as a service using a powerful servers grouped together in a clusters. Then cloud computing is a cost effective and simpler, benefiting both users and service providers. Then the key features are machine virtualization allows efficient resource use and reduces cost. See, with the virtualization, one physical computer can act like a many smaller virtual computers, allowing better usage of hardware and saving money on equipment. Then clouds aim to support multiple user applications simultaneously. The clouds are built to run many different apps for many users at the same time, whether it's hosting a website, storing files, or running AI models. Then the cloud ecosystem must be secure, trustworthy, and dependable. Views on cloud computing. Some people think big central system where everything is stored and managed from a single place. Others see the cloud as a network of many computers spread out across different locations but working together to deliver services. Then the next topic is the cloud landscape. In the past, organizations like companies or research labs used to buy and manage their own servers and computers within their buildings. Yes, and these systems faced major problems such as constant system maintenance. That is, they had to regularly fix and update their systems, which took time and effort. Then poor resource utilization. Often their computers were underused, so some sat idle while others were overloaded, which wasted resources. Then high costs of cloud computing. See, cloud computing appeared as a new model where users can access computing resources whenever needed, just like paying for electricity or water. That resolves or relieves users from these issues. Dynamic resource allocation. That is, cloud gives you exactly amount of a storage, memory, or a power you need, and you can increase or decrease the resources easily. Then cost effective maintenance. See, since the cloud provider handles repairs and updates, user don't have to worry about system maintenance. Then scalable computing services. You can start small and grow big, yes, and scale your computing power up or down depending on your needs, like adding a more capacity during exam season or a product launch. And then moving to the next, see cloud service models. The cloud landscape is based on three major service models: infrastructure as a service, platform as a service, and a software as a service. This diagram shows the three main cloud service models. So, infrastructure as a service provides basic computing resources like virtual machines and storage. Yes, then platform as a service offers a development environment to build and deploy applications. Then software as a service delivers ready to use software over the internet. Each model serves a different purpose, from providing infrastructure to offering a complete applications. Then see, as we have discussed in the diagram, this is the basic level of a cloud services where the provider gives you access to virtual computers, storage space, and networking, just like a virtual version of a real hardware. Here, you can install your own operating system and applications on this virtual machine. And you don't control the physical hardware like a servers, but you can decide when you want to use more or a fewer resources, like increasing storage and adding a new virtual machine. And think of it like a renting a computer from the cloud that you can use as you like without worrying about its physical maintenance. And example for this are Amazon EC2 and a Microsoft Azure virtual machine. The next is platform as a service. See, it gives you a ready-made environment to build, test, and run your applications without worrying about the hardware or the operating system. And it includes everything a developer needs, like a databases, development tools, and a runtime environments. For example, Java, Python, or a .NET. And the cloud provider handles all background things like hardware, OS, or a storage, so the user can focus on only on a coding and a building the app. And it's like getting a fully set up kitchen where you can just cook without buying or setting up any tools. And example of this are Google App Engine and Microsoft Azure App Service. The next is software as a service. See, it delivers ready to use software to users over the internet, usually through a web browser. You don't need to install anything. or a worry about updates is everything is handled by the cloud provider, and it is commonly used for a business tools like a customer management, finance, and a collaboration. For a user, sir, it's a simple and a cost effective. Just pay and start using, and no need to buy servers or a license. And for providers, it's cheaper than a traditional software delivery since they host everything in one place. And example for this are Google Docs, Salesforce, and Microsoft 365. So thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more insights on cloud computing. And also check out our playlist for more in-depth topics. See you in the next video.